Welcome to Study Loop.
We know that when diffraction happens together with interference, the intensity has a profile that looks like I naught times cos square phi by 2 times sine beta by 2 pi beta by 2 squared, where phi, notice that this is the diffraction term and this is the interference term. That is, this phi is due to the interference from the light, between the light coming from two different slits, and this phi is equal to 2 pi lambda a sine theta, where a is the distance between the two slits, and beta is 2 pi by lambda d sine theta, where d is the width of the slit, width of each slit, which we suppose is the same. Now, in our case, we have the diffraction pattern like this, and within this, we have an interference pattern which has exactly 7 minima. Let me draw this properly. Like this. These two maximas coincide. Now, as you can see, that is 1, 2, 3, 4, 5, 6, 7 maxima. Now, we'll just consider this. Now, for the diffraction pattern, beta here, beta by 2 is equal to 0 here, and beta by 2 is equal to pi here, because when beta by 2 is equal to pi, sine pi becomes 0. So beta goes from 0 to 2 pi within this length. Whereas when we consider phi, we know that this is the cos square curve and it goes 1, 2, 3, and 4 full cycles. We know that cos square theta has a cycle of pi. So this corresponds to pi. And this whole thing corresponds to a change of 4 pi in phi by 2. So that is phi by 2. So phi goes from 0 to 8 pi within this interval, when beta goes from 0 to 2 pi. So beta by phi is 2 pi by 8 pi. And we know that beta is 2 pi d sine theta by lambda, and phi is 2 pi a sine theta by lambda, giving us d by a, which gives us d is equal to a by 4. This is already given in the question though. So just to make it clear, let's call this angle theta 1. Then beta phi at theta 1 is equal to 2 pi by lambda a sine theta 1, which we know is 2 pi. 8 pi. And beta at theta 1 is 2 pi d sine theta 1 by lambda, which is equal to 2 pi. Now, let's go to part A. Similarly, in this case though, in this part A, within the diffraction minima, we have 5 instead of the 7, which means we have 1, 2, 3 on one side, 4 and 5, which gives us 3 full cycles of cos square theta, which means if this is theta 1, at theta 1, phi by 2 is equal to, as we know that each of these cycles is pi, this will be equal to 3 pi, and beta by 2 is equal to pi. So beta by phi is equal to 1 by 3 at theta 1, which gives us d by a, which means d is equal to a by 3 in this case, as opposed to the previous case. Now for part B, we'll have to draw the curve. We'll have to take the first case. We'll take the first case and draw the curve basically. Now we know that our curve looks something like this. And this was the diffraction curve, and the interference curve looked something like 1, 2, 3, 4 in the first case. Now, this corresponds to the change from 0 to pi. Then we have our first maxima for the diffraction pattern, which happens at, we know that sine beta by 2, beta by 2. So beta by 2 needs to be, at this point, beta by 2 is equal to, at this point, beta by 2 is equal to 3 pi by 2. Which means beta is 3 pi. So this is half of this. So because we have 4 full cycles here, we'll have 2 more cycles, 1 and 2. Now we simply multiply these two curves. That is, we simply fit this curve into this socket. So we start like this. This is the first one, second, third, fourth. Notice that the fourth one goes to 0 before. This is supposed to be the maxima, but then you have the fifth, and then you have the sixth. So that gives us 1, 2, 3, 4, 5, 6 maximas. So within the first maximum to the central maximum, the pattern will have 6 maximas.